Right, so these right here are called qualitative graphs, and these are pretty basic ones because they're all remaining the same, whether they're increasing, decreasing, or remaining constant the whole time. But a qualitative graph is generally just a visual representation of a situation. Uh, as you can see, none of these graphs have exact numbers on them. So I can't look at this and say, oh, at time of 5 seconds, the ship's distance is 20 feet. But I have a visual representation and I kind of get an idea of the situation just by looking at the graph. So letter A is saying a ship floats in the same place offshore for several days. It's remaining in the same place. And if you look at my graph, all the options are the ship's distance to the shore over time. So over time, it's remaining in the same place. The distance should not be increasing or decreasing. It should be remaining constant. So the correct answer here is letter A. Now, I don't know, looking at this graph, I don't know what the distance is, but I can see it's remaining constant. Whatever it was at the start, it's staying that same distance at the end. If I were to choose this one here, this would be like the ship coming closer to shore because the distance is getting closer over time. Wherever I started, however far away I started, it's now closer than it was at the end of the time. So I would not want to pick here. This would be the opposite. This would be like starting out close to shore, and then over time, my distance from the shore is increasing. So I'm going away from the shore. That'd be like going out to sea. So that's not what's happening here. And this one here is really just like impossible. This is a slope that is undefined. This is like saying at one single time, say this time is 5 minutes. At 5 minutes, I have a distance of 0 feet from the shore. At the same time, a distance of, 50 feet from the shore. That's impossible. I can't have two different distances at the same time. So that is just an impossible representation of this situation. In number 2, or letter B, a roller coaster picks up speed on the track. So over time, the speed is going to increase. Well, I'm going to pick this one right here because as time goes by, the speed is increasing. Again, I don't know the actual values, but I can see I started out at a lower rate, a lower speed. And by the end of the time limit on the graph, I have a higher speed. This option right here would be the speed remains the same over the time. It'd be like if you were in a car, you'd have cruise control on. Your speed is just going to remain the same over time. That is not what we're looking for here. This would be like the end of the ride. The roller coaster slows down because it is decreasing in this segment. So I'm starting out at a higher speed and I'm finishing at a lower speed. And then once again, this would be an impossible representation. So this is saying at one single time, I have a speed of 0 miles an hour, but I also have a high speed mile per hour. That can't happen at the same time. I can't be not moving and moving fast at the same time. So that would be an impossible representation.